The printer is ready for printing, and it is the time to make something to meet my purpose. Hi, welcome to Slow Engineering. I'm David. I modified the printer to use PA12 with carbon fiber material, with PVA as support for the future. Today I will test the first part, the PA12 with carbon fiber material first. Before printing, I realized the PA12 is hard to adhere to the clear glass. This makes me buy a sheet of PEI to attach it onto the glass. The glass with PEI still provides the flat surface for leveling. The second part is the drying. PA12 nylon will absorb moisture in the air. This will cause the material hard to extrude properly and also make the structure weak too. I put the filament in the drying oven for 10 hours at 80 degrees Celsius to make sure the filament is fully dried. Next, I put the filament into the dry box to prevent it from moisture. I already pay a lot for my filament with moisture. Never underestimate the moisture, even if you already provide a humidity control environment. Okay, let's move on to printer preparation. The first one is the nozzle. Carbon fiber is an abrasive material. It will wear out the extruder gears and the nozzle when printing. So make sure to use the hardened nozzle to print the filament with carbon fiber reinforced material. Here is the vanadium nozzles from Slice Engineering. Using these nozzles to prevent the grinding. The extruder gears are packed with the BMG X2M extruders, which the description at the selling page shows they can be used on carbon fiber material. So I just left it as default. Time to print. I loaded the filament and raised the nozzle temperature to 260 degrees Celsius. The bed temperature raised it to 60 degrees Celsius as the provider recommended. It prints smoothly like PLA and unlike the pure PA12 I have. Still, I need several test prints to calibrate for this material. The flow rate for line width, the retraction settings, and the last, dimension calibration. I found some information talking about how nylon will absorb the moisture and change its mechanical properties. Here is an example of one of the features. A single layer with my channel name on it. It was like a plastic sheet when I just removed it from the heat bed. After several hours of moisture absorption at room temperature, it becomes flexible like tarp. And another feature that might be critical is the dimension accuracy. Nylon also expands when absorbing moisture. So, if the parts need accuracies on all dimensions, nylon might not be suitable. For most of the case, the clearance for this expansion needs to be considered when designing the parts. For this material, I might use it for mechanical applications. Thank you for watching. Don't forget to like, share this video and subscribe to this channel if you learned something. Or consider becoming a Patreon supporter. See you next time.